We have two special log functions. There's what we call common log. This is the one that your calculator has built in to it. Your calculator has, when you hit the log button, it's automatically doing log base 10. Why base 10? We got 10 fingers. In other words, on your calculator, the log of 10 is saying 10 to what power equals 10? 1. When you type, your calculator is saying 10 to what power equals 100. 10 to what power equals 100? 2. When you go log of 1,000, your calculator is saying 10 to what power equals 1,000? 3. That means if you go log of 999, should be an answer a little less than 3. Now, we don't really talk about this. We don't do exponents with decimals very often. But, Hannah, what that's saying is 10 to the 2.999565488 should be really close to 999. I've rounded off, but look, we are pretty close. 998.99, that's close enough, 999. So your calculator has that one built in. So look up, my children. We're going to do some question and answer orally. Carson, look up, my friend. What's the log base 3 of 9? What that is saying is 3 to what power equals 9? 3 to what power? This is the log definition. Mark. 2. What's the log base 2 of 8? 2 to what power is 8?
3.
Okay. 3. What's the log base 5 of 25?
2.
2. What's the log base 5 of 5?
1.
5 to what power is 5? 1. Ready? What's the log base 5 of... of 1? 5 to what power is 1?
0.
Ah. What's the log base 25 of 25? 25 to what power is 25?
1.
You ready? Darian, you going to make it? What's the log base 25? 5. Now, this one was pretty good. Everyone was, 5 squared is 25. This is saying 25 to what power gives you a 5? What mathematical operation turns a 25 into a 5? Square root? What's square root as an exponent? Flower power! What's square root as an exponent? More specific, what's square root at what fraction? What fraction is it? Anybody? Yep. So, logs of other bases. Oscar, if you know your exponents, they can be done in your head, as long as they work out evenly. Now, if I said, what's the log base 6 of 19? That's a decimal of some type. And because my calculator only has base 10, I'd have to teach you, there is a trick. In fact, if you want to know, it's this. If you want to find the log base 6 of 19, turns out it's the log of 19 divided by the log of 6. That's called the base change rule. It's really handy. It's why your calculator only needs one base. Don't believe me? 6 to the power of 1.643322684 I know, but I want it for the visual effect, is 19. Okay? So your calculator, Brendan, only has 2 logs. Wait a minute, I thought you just said it has 1. Actually, this is also a special log, the ln. It's French for log natural or natural log. Often in calculus, we just pronounce it as ln. Pick up your pencils, here we go. 2 special logarithms, common logs, using the log key. Common logs are log base 10. In fact, it's so common that if you write y equals log 10 and you don't put a base, I'll assume you mean base 10. I'll assume you mean base 10. The same as if you go 5, I know it's 5 to the 1. You don't need to put the 1 there. I'll assume you mean 5 to the 1. That's the common exponent on everything. So to graph y equals log base 10 of x, we could graph y equals log x over log 10, but because it's the base 10, we can just go log x. It says verify this on your calculator. We're not gonna. Then we have natural logarithms. This is that weird, Brianna, base E that the textbook and I haven't really done a good job of. I wore my base E shirt a couple of days ago. E, it turns out, is another really handy base. In fact, to be honest, Grayson, as soon as you get to upper level math, you use base E more than any other base. Why? Calculus. Why? Calculus. Why? Giancarlo, it has some you were asleep, it has some very handy properties in calculus that I won't go into now. But ln is base E. What that means is if you go ln of e to the 1, you'll get 1. E to what power is e to the 1? E to the 1 is e to the 1. Turn the page and wake up. Get your graphing calculators out and handy. It says, investigating the value of big A, the number in front of, the coefficient in front of the log graph. What did big A do to the exponential? It told us the y-intercept. The y-intercept actually wasn't 0, 1. It was 0, A. It could make it a bit steeper, and it can flip it. Well, let's look at y equals the log base 3 of x. Get your graphing calculators out. First thing we're going to do is go into the graphing menu, delete any graphs you have there. Anybody not have a graphing calculator? Now's the time to sheepishly fess up. I'd rather have you tell me and I'll loan you one, but I want you to practice and follow along. So anybody not have one? Now is the time. Got one? 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 Holy smokes, have I got 100%? Wow! You made my day. I've got something in my eye. Excuse me. I'll be okay in a moment. Okay. Change the view window. How do I change the view window? Shift F3. Don't hit straight F3. Shift F3. What do I want to change the view window to? Whatever this graph here says. Looks like this graph goes from -1, right there. I've covered mine up. How far right does yours go?
It goes to 10.
To 10? So x min -1, x max 10. How low does your graph go? Oh, scale 1. Oh. Down arrow, down arrow, down. How low? -3, a little bit past. I'll go -3.5 and +3.5. Scale 1 works well. This other stuff I don't muck around with, but x min, x max, y min, y max. Is there anybody that can't get there? Now is the time to ask. You okay? You're there, Brianna? Because you're looking stunned. You good? Oh, okay. It's the last block of the day. Everyone's a little tired. Go back to the, here. I went from -1 to +10, and then I went a little bit past -3. So I went -3.5, +3.5. On all of them, I picked a scale of 1, because that's what it looks like this graph paper does. Is that okay, Brennan? First one we're going to graph is this. What base is this log? My calculator doesn't have in base 3. Well, it does sort of. It's going to be log x divided by log 3. That's the base change law. And it's going to look like that. Anybody not get that? We're good? Let's graph the second one on the same grid. It says graph 2 log x over log 3. I wonder if it's going to be steeper or shallower. I think that's what's going to change. Oh. So it looks like it's shallower here. It gets kind of steeper here. Is that okay, Zach? Okay. Okay, let me pause and I'll come look. So if I make a sketch of, because I got colors, I'm going to do this one in blue. Looks like it sort of did that. Yes? Is that right? Hey, what do you think a negative is going to do? What did a negative do to the parabola? Flip it. What did a negative do to the exponential? Flipped it. What would be nice if the negative did to this? It would be lovely if I got, let's find out. So for y3, I'm going to go negative 2. And then to graph log base 3, that's log x divided by log 3. Sure be nice. Ha! It did flip it. It did this. This one here. And I was vague on purpose because you need to learn how to graph these, right? Kind of like that. Okay. Then we have the last one. There's a negative, but instead of a 2 in front, what do we have? A 1 over 2, a 0.5. Negative 0.5 log x over log 3. Oh, too many 3s, Mr. Dueck. So this should give me 4 lovely graphs. Did I type that in right, Mr. D? Yeah. Thanks, I did. Negative 0.5 log x. Yep. Okay, draw. Okay, so it, Are there any differences, it asks, in the answers if they're fractions? Not really. Here's what I want you to notice. We're going to get to D here. First of all, if the base is bigger than 1, the graph increases from and A is positive. What we're going to do is, instead of writing this out in English, we're going to do little sketches. So, clear whatever graphs you have here. Delete all. Delete. 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 And this here, for bases bigger than 1, let's use b equals 2. For bases between 0 and 1, let's use b equals 1/3 as our example. If a is positive, let's use a equals 3. If a is negative, let's use a equals negative 3. And let's kind of put all this together. So what if I had negative 3 but a base of 2? Log x divided by log 2. What's that going to look like? That. You get a graph that does that somehow. Probably steeper than that, actually. What about if the base is a fraction and a is positive? What about if a is positive and bigger than 1? How about 3? And the base is a fraction, so log x divided by log of 1 divided by 3, or 1 fraction 3 button. If you use 1 divided by 3, you got to put it in brackets, or you can use the fraction button, which automatically puts it in brackets. Either way is fine. What do you get? Oh, looks pretty similar. What about, okay, here, if the front is negative and the base is a fraction? Oh, what if I take this graph, leave the base as a fraction, but just make the front negative? I'm going to go shift, insert, negative. Oh, that didn't work. There, now it worked. Negative 3 log x divided by log of 1/3. What's that look like? And I get that. Really, I should move this a bit further back. There we go. You okay, Zach? Thumbs up. Let's summarize everything on the next page. Whew. Here we go. And then we're going to practice and shut up. I'll give you time to work on this homework. So here is the summary. This is what I want you to know. It says, use the information to complete the following. If we're talking about y equals a log base b of x, the x-intercept is, well, let's look at a specific example here. Let me delete what I have. Let's graph y equals 2 log x over log 3. Here is a log base 3 of x. If I hit draw, what's the x-intercept? Let's see. I want to look for x-intercept is also called a root. Yep. That hasn't changed. What's the y-intercept here? It's a trick question. None. What's the domain? It's the range of the exponential. The exponential was everything above. The domain is everything to the right. x greater than 0. What's the range, all reals? There's a vertical axis, there's a vertical asymptote. It's the y-axis, which has an equation x equals 0. Okay. When A is positive and B, you know what? Let's write an example. When we have y equals 2 log base 3 of x. There's an example where A is positive and the base is not a fraction. Jordan, you with me? I know there's a distraction there, but you with me? Yeah. Okay. When I have, oh, here it is. The graph goes from quadrant 4 to quadrant 1, and it increases. That doesn't look very good. Let's try that again. What about if A is positive but B is a fraction? Oh, okay, let's change that. Let's make B 1 fraction 3. Starts in quadrant 1, heads down in quadrant 4. Decreases. So we have this, we have this if you're looking for shapes. I can't quite fit an easy way to draw the shapes. I'd kind of like to, but what if A is negative and B is bigger than 1? So what if we have negative 2 log x over log 3? Looks very, very similar to when B is a fraction. It decreases. What about when A is negative and B is a fraction? Negative 2 log x divided by log 1/3. Oh, you get that. In fact, these two look alike and these two look alike. Y equals log base b of x is equivalent to x equals b to the y. It's the inverse of y equals b to the x. B is the base. The reason we use the letter B for base is it's the base in the exponent and in the log. Pam, you going to make it? Give her a little nudge. She needs some help.
I'll make it.
You going to make it? Okay. Ah! No? Got some of the back row there. Couple more, we're done. Example 2 says, state the inverse of the following functions. Y equals log base 3 of x. Here's the inverse. What's the inverse of y equals 8 to the x? Y equals log base 8 of x. Example 3 says, which of these could not be a log graph? What was that?
The third one?
Why, Taylor? You're right. Third one. Why? Jordan, what? More specific, which kind of an intercept?
Y.
Because I asked you to. Which kind of an intercept?
Y.
Because I asked you to. Which kind of an intercept? I'll never get tired of that joke, ever. Because I asked you. Why? Because I asked you. Some of you are like, I don't get that at all. Now, got to be careful. Exponentials have y-intercepts. They cross the y-axis. So if any of these crossed the y-axis, they couldn't be log graphs. In other words, if the graph did this, that can't be a log graph because we said the domain is everything to the right of 0. But log graphs have x-intercepts. Taylor was right. She just didn't know why. Story of my life, Mr. Dueck. Well. So, what did I assign last class? Number 1. Number 2. Number 3. So, I can now talk about number 4. I think you can do C. You can do D. And you can do all of number 4. Okay. Number 5 is important to be able to do, and it's going to seem really hard, and I'm going to let you struggle with it. But when I go over this next class, you're going to say, well, that's it? And that's it. No to 6, no to 7. And I think I already assigned all of number 8. Also assign number 9. You're all tired. I'm tired too for some reason. I don't know why. So I'm not going to throw more stuff at you. We're going to continue with applications of logs and exponentials on Wednesday. But this is your chance to get caught up. Okay?